look at part B of this assignment. I did the part A in my previous video. Here we are going to look at the part B. Part B is keyboard scanning, and here quite often microcontrollers are used to drive devices which acquire information from human as well as the variety of other tasks they can perform. Obtaining this information is usually a very slow process, as a microcontroller is operating much faster than any way a human can deliver information. One of the most common methods to provide data to device is through a keyboard, through a keypad or keyboard. We see these everywhere. Keypads and keyboards can have any number of keys which need to be checked for activity. The simplest way to do this is to have a switch connected to each key. Although simple, this method requires wire for each key. Virtually no microcontroller offers that many inputs. Your typical PC keyboard has over 100 keys. However, there's only a fraction of wires compared to the other keys connected to the internal controller. Determining which single key is being pressed is done by process known as scanning. The figure on the right shows the connected schematic, and this is a figure of the keypad in TRISM 11. We can drive the signal on PC03, and we can read the signal on PC4 to 6. When a button is pressed, the associated horizontal and vertical wires are shorted. For example, pressing 5 will short PC1 to PC5. If no button are pressed, PC4 to 6 will all read as 1 because of the pull-up resistors to the supply voltage. To determine if any key is pressed, we can set PC0 to 3 to 0 and read PC4 to 6. If any are 0, then a key has been pressed. Now we need to know which key was pressed, so we start scanning. This process activates only one row at a time by setting only one of bits of PC0 to 3 to 0 and the others to 1 when we read PC4 to 6, and if one of them is 0, then we know it came from the PC line that was set to 0. If none of the PC4 to 6 bits are 0, then we move on the next line by setting another bit of PC0 to 3 to 0 and the others to 1. We do this for all 4 lines. This process can be tedious, but it can be simplified by using tables. This isn't necessary for this assignment though, so you may use as much as code as you need to read PC4 to 6. Simply load the port C MCU register. Similarly, write PC0 to 3 store to the port C MCU register. Extract this file from the assignment. Open it in TRISM 11. Connect the keypad by going to the connect keypad menu. It will automatically connect to PC06. Follow the comments in the next code on what to do in general. A good approach is to hold the keypad and wait for something to be pressed. Next, scan each row and save the port C result of each scan into row plus X, and where X is 0 to 3. You can process them later, then wait for the keypad to be released. The inverse of this first operation. Lastly, process the individual raw data. It is easier to use one register ACCA, for example, to keep track of the result, and another ACCB, for example, to perform the bitwise operation. To determine which key was pressed, start at 0, set ACCA to 0, and if it passes the 0 key check, leave the subroutine. Otherwise, increment ACCA and test for the next condition, and repeat until all possibilities are covered. Your subroutines in get keys should return a value from 0 to 11 in ACCA, where 10 is this star key, and then 11 is the number sign. When you run the program, it will display the hexadecimal representation of key pressed on the LCD. Once all the keys are released, unselected from the key pad, selecting multiple keys will generate unexpected results. This is compromised with keypad or keyboard scanning. Okay, so let's look at this. and this is the initially provided one, and we have to do all these changes, and there's nothing else here to be done, but here's the part the main codes are involved, and it's a whole lot of them. That's why, you know, like I don't want to just start doing from scratch. I just did it already. So let's go through the explanation. So this is the one has to be completed, and if you notice, this is already there. LCD hex 1 is there, LCD hex 0 is there, nothing before there, and the gate key, this is the part we have to do, and this is the one completed one, and hex 1 hex 0 is right here, and I go to, you see all these codes for this. So first, PC 0 to 3, we load accumulator A with, this is 40 bits 0 to 3 zeros, and first we load accumulator A with this number, and then AND A and store AND A port C, and then store in the accumulator A port C, like that. There's a lot of, you know, playing with the numbers and storing. Some of them are ANDing and subbing operation, and when we AND and sub, when it's 0, it means key is going to be pressed, like that. So various logical operations has to be done to accomplish this. Okay, this is all of them, and then here we have the process. Now we are doing the same thing with the accumulator B, increasing accumulator V, and then LDAB, loading accumulator B with the B represents rows, okay. So this is basically it, and then we create the print hex 2 print hex 2, and then in this one we push to remember 8-bit values, and then LSRA for the left shift. It will shift the higher 4 bits to the down 4 bits. We do this 4 times because we don't have anything else to does this operation. And then here branch to subroutine LDS x1, it goes to this and do this process, and then pull a restore back to. Okay, and that's basically it. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next